my presentation is on least squares. First, we're going to talk about a little bit of history behind it, and there's three people that are talked about during the history. First is Gauss. He's a German mathematician, and he lived from 1777 to 1855. In 1795, he developed the least square analysis, and then in 1801, he showed it by finding the future location of an asteroid named Ceres. Sometimes he published his work, other times he just wrote it as a cipher so that other people couldn't read it. And this way, his work, if other people found out after him, he could be like, no, actually I figured it out first, but then people weren't claiming his work. He published his secrets of least squares in his theory of motion in the heavenly pieces, or heavenly bodies. And then the next person is Pizzi. He's Italian, and he was the person that originally discovered the asteroid Ceres. And after he discovered it, they couldn't find it. It disappeared, and they hadn't found it for a very long time. And then Zach, he was Austrian, and he said that without the intelligent work and calculations of Dr. Gauss, we might not have found Ceres again. And then, just so that you would kind of know where it is, here's Ceres down here in the asteroid belt, and then there's Earth and the Sun. But they couldn't find it because it had been behind the Sun for so long. Okay, this is a lot of words and humble jumble, so it's easier just to explain it as a problem. Okay, so we'll do an example on the board. So least squares is used to find the line of regression, so trend lines. So if we have some points, and I'm sure you guys have all done this in other classes, but you have 1, 2, 2, 4, 3, 5, 4, 5, 5. So we have these points. If we find the mean of both x and y, we know that point 34 is on our line of regression. So 3, 4. That point is on our line of regression. And then we can go on to find x minus x bar of this, which is -2, -1, 0, 1, 2. And then we'll find and then you use those and you find x minus x bar squared. 4. So the whole point of doing this is we're trying to find y equals b0 plus 1x, which is our line of regression. So to find b1, we take the sum of x minus x bar times y minus y bar, which is the sum of this, which is 6, over the sum of x minus x bar squared, which is this, which is 10. And then we get 6 over 10, which is 0.6. And then to find your y-intercept, you already know this point, which is your means of both. So then then you can do, put it in for y and x. So 4 equals 0 plus 0.6 times 3. And you get B0 equals 2.2. So then your line of regression is and that is using least squares to find the line of regression, which is exactly what this slide says in funny words and funny notation. So the uses of least squares today is like in science, in finding trends and stuff like that. And then computers can use it to draw lines and smooth curves through data. And then obviously we can use it in astronomy because that's how Gauss found Ceres. And then trend lines, an example of that can be like the trend line that exists between age and the length of cave serolites, which is in your book. And those are my resources and my picture sources.